Can everybody hear me okay? All good in the back? Cool. All right, so we're gonna get started like a minute early today, just because this lecture is like a lot of stuff that we have to cover, and typically it'll run long a little bit. But if you weren't able to get the attendance link, just come to me after. We'll give it to you, or we'll put you in manually. But yeah, so today we're going to be talking about views and introduction to Git, in case you're not already familiar. And we're also just going to give you like a pretty soft introduction to how to use the Android Studio Editor. Yeah. So we're the team of course instructors. I'm Adam. I'm a CS and music major. I've been on active for 4 semesters now. And previously I've worked on Eatery and Ithaca Transit. And Shirley?
Hey y'all, I'm Shirley. Let's see. Yeah, I'm a junior studying CS and math. And yeah, I've been on app dev since spring 2020. And yeah, I've worked on Polo and Pear.
And here's the rest of the team, in case you're curious. These are going to be TAs for the course, so you'll be like running into them. They hold office hours, and office hours will be starting this week, but we'll get into that. Okay. Now let's talk about why Android. So Android is the world's most common mobile operating system, and for that reason, like job demand directly correlates towards Android. So if this is something that you're interested in pursuing as like a professional tool or to get like an internship or something like that, Android is a great way. The other reason is because Android is an open source operating system, meaning that the source code for Android is public. Anybody can change it. That's why Samsung has their own version of Android, which is different than Google's version of Android, which is different than like Xiaomi's version of Android. They're all different, and so that allows for a lot of customizability and a lot of really interesting stuff to happen under the scenes that iOS and Apple doesn't let us do. Okay. So just a little bit of logistics about the course. So we have an attendance policy just because we have so few lectures. There's, I believe, only 6 lectures throughout the entirety of the course. So we're only going to allow 1 missed lecture. And so we enforce attendance using an attendance form. But if you're like late, it's like chill. We record these lectures and stuff, and we're not trying to like penalize anybody. Everybody passes the course as long as you do your work. I'll preface that. But yeah, and for enrollment, if you have any issues enrolling, let us know. You should be enrolling for 2 credits under CS 1998-602, and you should be taking it as due. If you have any issues, come to us and we'll help you. The add deadline is October 1st, and the drop deadline is October 21st. So if you just like want to try out the course and then you're like, maybe I don't know if this is for me, you have that time. Or if you're thinking, I'm gonna maybe just pull up to the first few lectures, this is the add deadline. So getting help with the course, we have a campus wire, which is sort of like Piazza, if none of you guys have used campus wire before. That's where you can ask questions to the course staff, and we'll do our best to respond as fast as possible. And we have office hours. I believe we have 6 or 8 office hours every week, some in person and some on Zoom. So there's flexibility there. And what we're doing new this semester is after every lecture, me and Shirley will stick around for 1 hour to help you get started on the homework. Or anything else, just to ask questions, just like a little impromptu sort of office hours, or if you just like want to talk, all of that is cool. And also we have CMS, where you guys will be uploading your assignments, your homeworks. And if you ever have even late submissions, all of that is tracked on CMS. And our course textbook, which is the go-to source for all things Android. There's a lot of interesting like knowledge there. So if you're like, I saw something in lecture, it was kind of quick. So this is me telling you, don't take notes. Do not take notes in this class, because all of the notes you need are on the course textbook. If I were you, I would just sit back and try to internalize what I'm saying as much as possible and just use the course textbook. All right? So in terms of schedule, like I said, we have 6 mandatory lectures, and we have 6 projects that accompany each lecture. And all of our lectures will be uploaded to the active YouTube channel. Once again, if you need to know where that is, the course website or course textbook will help you navigate that. And we're also going to have 2 bonus lectures. These are pretty cool. What we do is we get some members of the course staff who are passionate about a topic to just like give a bonus lecture. Like we had a member, Chris, do Google Firebase for tracking like the analytics of your apps, like how many clicks you get and stuff like that. And so these are like really cool ways to like boost your hackathon project at the very end in like really unique ways and learn like industry skills that other people know and just like share a lot of extra, I guess, expertise. But going to a bonus lecture will be extra credit. So if this is something you're interested in, we will be rewarding the initiative. And at the end of the course, you'll be doing a hack challenge where people from the other active courses work with you and creating an app together. So people from the design class, the iOS class, the backend class, we all come together and make like a full stack app together. And this is just the schedule. So just to get a little taste of what's to come, we're going to be making like a notes app, a wallpaper app, like a Spotify playlist sort of thing. Yeah. So about course grading, to pass the class, you need to get a 70. And I'd say we're pretty generous in terms of grading. So like you submit something, you'll probably get at least like 3 points, 4 points. But here's the thing, if you're submitting something and it's like, you tried your best, but you can't get it to like build or there's something wrong, submit a readme.txt. Don't just not submit anything or submit a broken file. Submit a readme.txt, tell us what the issue is, and like we're not in the business of like penalizing you guys. Like we want to work with you guys and like make sure that you can learn as much as possible in this process. So make sure you submit a readme.txt file with your stuff to let us know if there's anything wrong. So we have feedback forms that you have to fill out every week. This is just for us because we want to make sure we're doing as best as we can. So having real-time feedback is super important for that. And it's worth like only 1 point for each one that you submit. But it's nevertheless something important, and you'll find them on the homework page on our course website. Our late policy is we give 6 slip days, and you can use a maximum of 2 slip days per homework. So every homework is going to be due Sunday at midnight, and you can potentially then do Tuesday at midnight if like you're having a busy week, you have a prelim or something like that. If there's ever any extenuating circumstances, reach out to us. I think we're pretty accommodating. But here's the grade schematic. Some of the later projects are weighted a little heavier than the early projects. Okay, so in terms of doing the assignments, we're going to be having partners this semester. So everybody will be randomly assigned to one partner, or if you're the odd group out and you have an odd number of people, then you'll be a group of 3. This is why using GitHub will be so important this semester, because we realized in previous semesters of the Hack Challenge, a lot of people started working together and they never knew how to work with other coders on one project, one code base before. And GitHub is like the most important thing to use in industry, in computer science in general. And so for that reason, we thought it's very important to teach and something you'll be using throughout the course now. So if you get to 3110 and you start using GitHub, you'll immediately be familiar with it. So when you submit, you'll be submitting as a zip file, and you'll also be submitting a screenshot of your GitHub repository. I say screenshot because we want the repositories to be private, and we don't want you guys to have to go through adding up as a collaborator to the GitHub repository and everything, just because that can be a little bit of a headache. And we want to make sure that you're using GitHub. You guys are actively like learning it with your partners and everything. But we're not gonna like helicopter over you to make sure that you are. So just submit a screenshot of your GitHub repository and the zip file of your code. And if you want to know how to export your Android project as a zip file, that's also on the course website. But we'll talk about in the demo today. So that's what you're going to be submitting on CMS. And of course, throw the readme.txt into the zip file if anything goes wrong. All right? So academic integrity. We're required to talk about academic integrity. Basically, let's be honest, everybody uses Stack Overflow. It's completely fine. Just use it within like a reasonable amount. So like it's unreasonable to expect you to memorize random Android code, and for that reason, like we encourage you to use the internet, but if like more than 50% of your implementation comes from like a Stack Overflow post, then something is wrong. But if something is fishy, we have access to MOS, and we can run it on MOS. But let's not get to that stage. And so with partners, so you're working in your groups of 2 or 3, and you shouldn't really be talking to groups outside of the people in your partners. You can talk about like general things, but not like implementation specific stuff. And your partners are going to be randomized. This is to encourage you to get to know everybody in the class and foster a sense of community. Like I said, the GitHub repos have to be private. This is super important. If you make it public, then you're violating the AI policy because this is supposed to be just within you and your group. With other groups, just use like a reasonable amount of talking and don't say too much about your specific implementation. Okay, now we're going to talk a little bit about Kotlin basics. So Kotlin is the language that we use in Android for Android development. It's we used to use Java 3 semesters ago, but Kotlin is the future of Android development, and so we decided to move with the industry just using Kotlin. Okay, so the first thing is that Kotlin is a statically typed language. So who can tell me what statically typed means based off of this example? What do you think? And any guess is a good guess. I promise I won't bite. No guesses. Yeah. Yeah, so does it not require like the, that's a great guess. Does it not require you to tell the explicit type of the variable when you, when you're declaring some value? So basically, that's the difference between like type inferencing and whether you have to explicitly type things. So as you can see in this example, right, we have some name and we set it immediately equal to some value, Leslie, right? This is a string. Versus, here is us explicitly saying that name is of type string and is equal to Leslie. So this is the difference between an implicit and explicit declaration here. And this is okay in Kotlin. This is something we are allowed to do. This is a language feature of Kotlin where it's smart about its type inference. It can accurately inference a lot of types that are a lot more complicated than this string. So this is one of the reasons why we like Kotlin, because I don't know if anybody here has coded in Java. I'm sure many of you have, but in Java, we know we have to explicitly say, like, string name equals Leslie, and that string has been explicitly declared as the type. So, okay. Now let's talk about mutability. Okay, so who knows what mutability is? Who can tell me what mutability is? Yeah. The ability to change a variable, yeah. So the ability to just change things in general, right? So in this example here, right, we have some value name, which is being set to Leslie. Then we try to change name to Ada. So this is not something that we should do. Versus, we have var name equals Leslie, and then we try to set name equal to Ada. This is okay. So what's the difference here? The difference is the use of val and the use of var. So var is something that we use when we want to change the value. But val is something that we'll typically reserve for values that are going to be constant throughout the course of the program. So, so if I knew for sure name would be Leslie from the start of the program to the very end of the program, then I'll leave it as val name. But if I knew maybe halfway through the program, I want to put my own name in the place of Leslie's name, then I'm going to make name var, so that I have this ability to change the value. So it's no longer Leslie, now I can change it to Ada. Any questions about this? Oh, yeah.
Do values and variables use up the same amount of memory?
Do values and variables use up the same amount of memory? That depends on the type. Uh, so there's a memory allocation for depending on the type. So like as you know from Java, there's like primitive types and then there. But I believe everything is actually implemented as sort of an object type in Kotlin. Yeah, Shirley backing up on that. But even then, there's still differences in memory allocation. But we don't need to worry too much about that. Good question though. Yeah, so if you just want to learn more about how Kotlin works as a language, you can go to the Kotlin Clone playground. But one thing I will say though is Kotlin in use of Android is sort of different than like pure Kotlin. So just something to note. But if you want that extra experience, by all means. Okay, so now we're going to talk about SDKs. So SDKs are very important for creating Android applications, software development kits. So let's talk about what it is. So okay, each Android device comes installed with a specific SDK version. So an SDK version is basically just a number to correspond to some Android version. So maybe if you guys have iPhones, you know that like iOS 13 is some version of like the iOS operating system. So for Android, we have like Android 10, Android 11, Android 12, and there's an SDK that corresponds to every one of these Android versions. So here we can see Android 10 is SDK 29. So if I want to target a specific version of Android and all of the ones up to that version to a reasonable extent, then I should be using a certain SDK when I'm creating my Android applications. So Android has a lot of changes with time, as you can imagine. How Android looked like 10 years ago is completely different than how it looks now. The feature set is completely different, and there's just a lot of changes. And so for this reason, this is typically how it's divided through SDKs. One example I'll give you that's concrete is permissions. So permissions is something that was introduced in Android Lollipop, I believe. And it was something that said, if you want to like use the camera, it'll explicitly ask you, can I use the camera here? Versus before it was sort of just you subscribed to all of the permissions and app changes when you downloaded it. So it could ask you in real time. So I could own an app without giving it permission to my camera. Sort of like this sort of thing. But for me to actually do that, I need to target the Lollipop SDK. So this is something that sort of came new with that version of Android, and so I need that SDK to be able to code features for that feature set. This is actually why Google hosts that yearly event, Google I/O, because that's where they address Android developers and tell them about all the new features in Android. That usually becomes more like a press conference for like tech journalists and stuff. So minimum SDK sets the lowest possible SDK the device must have to successfully run the app. So this is our way of making sure that like super old phones can't run our apps if we know that it's going to like crash on it. And we can target certain SDK levels for optimal performance, like we just mentioned. So basically, this is an example with the Eatery app. So the minimum SDK is 26 for Eatery. So a very old version of Android, Android Lollipop 5.0, would not be able to run Eatery because it did not meet the minimum SDK requirement. But a new phone like that runs Android 10 on SDK 28 would be able to run Eatery. And typically, you don't want to set your minimum SDK like too high because otherwise a lot of people won't be able to run your thing. And Android Studio tells you what % of Android users you can cover with the minimum SDK that you choose. So if you're like setting it really high, we'll be like, hey, you only support like 10% of Android users if you set it at this. So it's nice and giving you statistics about that. Okay, and these are the statistics that it talks about. So you can see this is a little bit outdated now, but it says 75% of all Android devices are supported at the marshmallow level and above. And Android updates do usually come within 2 years of a phone's life cycle and continually come during that period of time. Okay, so that's it for SDKs. Any questions about SDKs? Okay, so we're going to move on then to Android Studio. And we're going to sort of introduce you guys into Android Studio, which is where you're going to be making your Android apps. So if any of you have used IntelliJ before, it's a IDE for coding in Java. Though I know in 2110 you use Eclipse. You probably have seen a sort of similar environment before. So we have the project panel, which is where you take a look at your file structure on the left here. This is where you go through all of your folders, your subfolders, and you can change the view. If you want to look at it as just project files, or you can organize it as Android-specific files. This is where you have your editor, and the editor is where you're going to be making all of your code changes. And this toolbar at the top is going to be where a lot of the interesting stuff we're going to be doing in terms of running on an emulator. So just to be clear, you don't have to own an Android phone to be able to test your apps. You can run it on the emulator. This bottom part here is where we can see the logger, which is in Android we call it the log cat. We can also see the console, and this is where we get like build errors and stuff like that. So this should all hopefully be a little bit familiar compared to other IDEs you might have used. So yeah, the emulator. The emulator is runs a virtual phone on your computer, and it'll automatically launch the app that you make onto it. And you can create the emulator to be like different levels of usually pixel phones. So I could run like a Pixel 2, Pixel 3, Pixel 4. And typically it's done by Pixel because Google, the developers of Android, are running or creating Pixels themselves, and so they have like in-house control over the Pixel experience. And it's typically pretty vanilla, not a lot of extra stuff on top, the same way Samsung would add things on top of like the vanilla version of Android. So this is where we're going to be testing our code, unless you own an Android phone. I suppose you could plug it in if you're brave. It can be a little bit slower just because it's like a virtual phone. So if you're like, man, my app is like really slow, it's probably just because it's the emulator taking up a lot of resources, but it's not too bad in most cases. But I guess we'll see in the demo today. So the logcat, I mentioned the logcat. Basically, the logcat is where we put messages that we want. So if you guys have coded in Java, you know system.out.println, right? This is how you like put stuff onto the console for you to see. So we don't do that in Android. We use something called log, and typically log.d. Log.d is our way of logging debugging snippets. The D is for debugging. Log.I is for info. Log.wtf is for, I don't know, but it's a thing. And so basically, we have two arguments. So whereas system.out.println, we take one string argument, log.d takes two. The first is a tag. And this tag is what will come up in the logger, because many messages are constantly being populated into our logcat. And so in our logcat, we can search for our tag. So like, let's say I made the tag like my debug message. And so I can search in my little logcat, my debug message, and it'll filter through everything that was in the logcat and only show me the thing that had that tag. And then it'll show me the message. So maybe that's the value of some string that I want to know, or something else. And so this is basically what we use instead of system.out. So I shouldn't be seeing any printing. I should hopefully only be seeing log.ds. But first off, any questions up to this point? And I want to stress, any question is a good question. I know I'm going a little bit faster. Yeah. Why is it called Logcat? I think it's sort of just like a cutesy name for like the Android logger. Yeah, nothing particularly meaningful there. Any other questions? Yeah. Works the same as a print statement. Sort of, yeah. It's a little bit different because when we're printing, it's going directly towards the console, whereas logs are sort of saved in like a very low level system thing. So like if like something went very, very wrong, you can like export the logs and like take a look at like what went wrong, even on the phone. But on like system.out.println, it's just on the console when you X out of println, it disappears. But for functionally to us, basically, yeah. Okay, any other questions? Okay. So here's a little example of logcat. So this is using some tag string, and then we put in the string Android under the variable name in. And in our little logcat window, we'll see this line here. But we'll keep it moving. Okay, now we're going to talk about views briefly. This is sort of like the front end part of Android, where we're sort of just putting together a lot of different pieces of the UI. So we do the front end of Android in XML. XML is a markup language. So I don't know if you guys are familiar with HTML. That's like another markup language. I think it's hypertext markup language. I don't know. But basically, it's the little open-close brackets you'll see like this. And we basically sort of use them as almost like Lego pieces to build front ends. So just let's run through this example really quick, because it's pretty self-explanatory what all the different views are. The first one here is in edit text. In edit text is a view that I use if I want to be able to input text, something that's editable, right? So in this search bar here, I should be able to edit what's in that search field, right? I should be able to type in something so that I can actually put in the thing that I'm searching for and get back some results, and it'll do something with what I typed in. So this is one example of an edit text. Another example of an edit text would be a login, right? What's my username, what's my password? That place where I'm typing in my username and my password, that's considered an edit text. So an edit text view is typically used for inputting and editing text. A button is exactly what you think it is. It's something where when I click on it, an action will happen. And I can predefine what I want that action to be. A text view is just text. So if I want to display like the title of something, or I want to say like click here next to the actual button, this is just a text view. So text on the Android app is in a text view, and an image view is for displaying images. In this example here, we have a photo of nasties above bare necessities. Yeah. Any questions about these four views? These four types of views? Okay. Next up. Okay, and now the resource folder, also known as the res folder. So the drawable folder is where we put images and icons. This is sort of just like random file structure stuff about Android projects. It seems like a lot, but once you open up Android Studio, you'll realize it's all sort of there. You don't need to like memorize this information. It's just so it's familiar when you see it. So the drawable folder is where we put images and icons. So like your phone's app icon. The font folder is where you put custom font files if you want like Comic Sans in your app. I don't know why you want that. The layout folder is where you put the XML file for all of your layouts. So that layout XML file is basically where I would be putting the edit text, the text views, the image views, all of those things we were just talking about would live inside of a layout XML file. And so those layout XML files would exist inside of the layout folder. And this is required for basically all Android apps. Whereas I could go without the font folder just fine. The MIP map is where you put icon images, which is sort of just like another type of image. Don't need to worry too much about that right now. And raw is typically where you just put like other unfiltered media, like videos and audio. And also, if we have certain values we want to use over and over again, or just we want to be like really clean about how we're making our app, we'll use like a colors.xml, dimensions.xml, strings.xml, or styles.xml. So like, for example, if I have the name of a dining hall, then I would probably want to put that in my strings.xml rather than hard coding the name of that dining hall over and over again. So I could just call on it. So here's an example with colors, right? I have some primary color, and I have the hex code for it. This is not something I want to be able to just pull up by memory. So this is my primary color. This is my primary dark color, my color accent. And so now if I want to call on it, I can just, within a string, say @color/color primary. So that's going to reference this one right here, this hashtag 008577. So this is like a very convenient way to be able to access values, and it's sort of like a separation of concerns sort of thing. Yeah. Sorry, can you speak up a little? Does it just parse all of which XML? The color.xml? Yeah, so colors.xml is a very specific type of XML. It's not just like some random name, like it knows that this is for colors. And same for strings. Like these are things like that are part of Android Studio practice. This isn't just like, hey, I happen to have a couple of strings, I happen to have a couple of colors. Let me just make something called colors.xml or colors and strings.xml. You see what I'm saying? Yeah. Okay. So yeah, now, so we were talking a little bit about XML files, but I'm sure you guys are expecting most of the coding will be done in Kotlin, and you'd be correct. So this is basically where we draw the distinction between class files and XML files. So building our interfaces and stuff, that takes place in an XML file. But the actual logic of the app and all of that sort of stuff is taking place in Kotlin in class files. And typically we call them activities. So by default, every time you're going to create an empty activity, which is what you do to start most projects, it'll be auto-generating a main activity class for you. And it'll have an onCreate, which is basically, when I create this activity, what's going to happen? We're going to go a little bit more into detail about this, but just know that this is basically just like the constructor of the main activity. This is like the main screen on my phone. So an activity can sort of be thought of like a screen for now. And like this code is auto-generated. Most people do not have this code memorized and spread it off the top of their head. So any questions on this? This is, I know, pretty important for the fundamental part. Yeah. Yeah, so what does the auto-generated code do? So, okay, I'll try to go over it like briefly, but basically what's going on here is it's calling on its super. So onCreate is the function that gets run when the activity is created. And on the creation, it's basically calling on the super constructor, which is even bigger in the like Android chain of like creating new activities and things like that. And this set content view right here, this is where we're basically setting the XML for the layout. So remember how I was talking about how we create the layout files in the XML? Like that's where we put the edit text. That's where we put all of that stuff. So this is where I reference it. This is where I say, hey, this screen that I'm talking about, main activity, is actually connected to this XML layout file. So r.layout.activity main is our way of saying, go to the res folder, look into the layout folder, and then pull out activity main.xml. Does that make sense? Any other questions? Okay. I'll try to move a little quicker here. So briefly on inputs. So number one is an edit view. These are event listeners and like different ways, or these are input controls, and we typically will use event listeners with input controls. I'll give an example. If I have a button, an event listener could be an on-click listener. So it's listening for the moment a certain event happens. Every time I click that button, it's listening for when it happens, and the moment it does something. So let's say I want to print hello world every time I click the button. The event listener for the button, in this case, an on-click listener, will listen for the moment I click the button, and then print hello world if I put that code within the event listener. So an event listener is just something that listens for a specific event, and the event could change depending on the input control. So buttons is different than like a seek bar, which is different than a checkbox. So checkbox is number 3. The seek bar is number 2. So this is something you'd use in like homework too. Something we'll see soon to change between a range of values. So imagine like the spectrum of colors. I could drag between like very low luminosity to very high luminosity. This is something you'd see like in Photoshop, for example. Radio group is like number 4. We have different options like in a multiple choice test. 5 is a switch, so you can enable or disable things. And 6 is a spinner for pre-selected options. But once again, no need to memorize any of this. You should honestly look up stuff as you need it. That's why we emphasize, don't take notes. All of this is on the course textbook website. Okay? So this is just a little case study of a button. So this is me in my layout file at the top here, creating some XML code for the button. So here's my little button. I set the width to be wrapped content, which basically just means however big the button is, just make it that big. So if I have like 30 pixels of width, make it 30 pixels. So it's wrapping the content up. And same for the height. This is auto-generated a lot of the times. This is like the typical default. And then I have an ID for my button, so I know which button I'm talking about. So later on when I go to my actual code, if I want to reference that button, I have an ID. So I know I'm talking about this button rather than a different button. Now in my main activity.kotlin file, what I'm doing here is I'm saying this button.set unclick listener, and it'll automatically, Kotlin will know what's going on. Android Studio will say, hey, looks like you're trying to set unclick listener. Just hit enter when it tells you that, and it'll automatically pull up this for you. Then within the brackets, you can put whatever code you want to happen. So what code would I put here if I wanted to print hello world? Who can tell me? Yeah. Beautiful. Yeah. So not system.out.println, but log.d, the tag, and then my message, hello world. Very good. Okay. Any questions about this example? Yeah. Does it matter what? The tag is just for you to identify it when you're like searching for it in the log cat. But I know sometimes like if you're working for a company, there's like specific guidelines about what the tag should be depending on what it is that you're printing. Yeah. If you accidentally use the same one, the same tag twice. No, that's fine. You're allowed to use the same tag twice. So if I wanted to like log like 3 different debug messages, and my tag is debug for all of them, then it's easy for me to find all 3 of those interesting messages. I can just search debug. Does that make sense? View groups. We're going to go through this quick because I don't think this is super important at this point, and we revisit a lot of this material. This is really just for scope to make sure that we're all familiar. So with view groups, basically, we have different options. We have a linear layout, which is just like stacking elements in our layout. So if I had a button and then another button, it would sort of be like button, button, button. Or if I change the orientation, then I could say button, button, button. This is just ways of organizing our layouts. Relative layout is basically you can organize things as relative to another. So like to the right of this element or to the left of that element. A constraint layout is like saying you constrain it to some other thing. Like you could constrain it to the screen's rightmost side or the screen's topmost side. And we could also have like a frame layout, which is imagine like putting things within frames and then framing the different things around. So, but once again, this is not too important right now. And now 2 more important things. The Android manifest is basically so it's the file that contains information about the activities in your project, this is where you put permissions that you need. So if I want to access the location of somebody, I have to explicitly declare it in the Android manifest. This is very important. And other system level things that I might need for my app also has to go here. It's sort of like the charter for your app. You shouldn't need to touch it too much unless you're doing a lot of permission stuff, but just so you know about it. So this is a common issue. A lot of people say, hey, I'm trying to get like this location, or I'm trying to get like some permission thing. And it's okay, did you declare the permissions in the Android manifest? So this is just something to know about. And also build.gradle. So there's two different build.gradles, which is sort of like a random name. It shouldn't mean anything specifically meaningful just off of its name. And the one we're talking about is the one that'll be like subtexted module. So this is where you set like the basic configuration of your app, which is useful if you're like uploading to the Google Play Store. This is where you put stuff about like the SDK version, I believe, as well. So if you guys remember, we were talking about the SDKs and the SDK, stuff like that. And you can also do third-party libraries here. So if I'm using like a third-party library to get HTTP information, or like pull from a backend, which is something you will do for the app challenge, then this is typically where I put third-party libraries that I use. So anytime you're like importing something, you can sort of think about putting it in the build.gradle. Okay. And now, very quickly, we're going to go over Git, since a lot of it will be covered in the demo. So Git is basically a version control system. So if I have code and I want to see the code that I used like 30 days ago, Git kept track of that. It allows for parallel programming. So if someone is working on some code and they added 3 functions, and I was working on some code and I added 5 functions that are different than their 3 functions, then now we have this sort of thing where we've both worked on the code in parallel. And how do we merge these things together? And Git is our solution for that. This is something that's used a lot in the industry. Basically, everybody uses some version of version control. It's sometimes called VCS. It's called that in Android Studio. And now, a quick distinction between GitHub and Git. Git is the version control system itself. And GitHub is just where the code is being hosted. So if I just created some project, I'm going to upload it to Git, but the whole thing that keeps track of like pushing it to the GitHub repo and everything, all of that is done using Git. Git is the thing that you install. GitHub is where your code is. Okay, and yeah, our repositories will be hosted on GitHub. Okay, so some basic ideas behind the commands that we can use with Git are pulling, committing, pushing, and merging. So pulling is when we're pulling from GitHub. This is when we're grabbing the code that's on GitHub and bringing it in our local machine. So let's say our friend just added 2 functions, but my code on my local machine is still old. So I'm going to pull from GitHub and get the newest version of the code that they just pushed. So to commit is basically saying, hey, I feel good about this code. I'm going to put it out to you're planning on putting it out to the GitHub repo, and you put a little accompanying message with it saying, just completed functions 2, 3, and 4. But it's not officially on GitHub until you push. So when I push is me actually then moving it to GitHub. So after I have committed, I can then push that commit to GitHub. And GitHub is very nice. In their systems, they have a branch sort of structure where I have a main branch, which is like the main code. This is like where everything is. But I could work on a branch that isn't the main branch. So let's say I have a branch just for working on a feature. And in case like that code screws everything up, we don't want it on the main branch. Because if it's on the main branch and it's screwing everything up, then there could be huge repercussions for our users. So for that reason, people will work on different branches. You probably won't need to work on different branches when it's just you and your partners. You can probably just directly push towards the main branch. And when you merge, sometimes you'll have conflicts. So if I had something on a different branch and now I want to merge it into the main branch, sometimes it'll say, hey, which code should I use? Because I'm getting some conflicting information between this branch and this branch. And GitHub has a really nice tool to help you fix those merge conflicts. But once again, I don't think you guys will be doing much on different branches. Okay, and this is under the course website, we have a Git and GitHub help where you can find all the download links and everything that you'll need. But Shirley is going to go into that. And yeah, now it's just to talk about the homework you guys are going to be completing for this week. So homework 1 is going to be intro to the editor. So what you're going to have to do, and we have starter code for you guys, so you don't have to go off with nothing. And that's going to be available on the course website. And we're going to assign partners to you guys on CMS after the lecture. And it's going to be based on your attendance survey. So make sure that you fill out the attendance survey. So you're going to have to create a GitHub repo. You're going to have to add your partner as a collaborator to the repo so that they can push and pull and do all of that. And then you're going to push your starter code to the repository. So you're downloading the repository, or you're downloading the starter code from the course website. Now you want to push it onto your repo. And then you want to make sure your partner can pull, push, and build the code successfully. Both of you should be able to run the code. And then work on homework 1, which is doing some to-dos. It's just fixing some broken lines of code, and follow the submission instructions that are on the course website. So homework 1 is very soft, very it shouldn't be too difficult. But of course, if you run into any issues, we have many office hours you can go to. You can always ping us, and you can always feel free to send me an email at any time. Okay. Any questions about the homework or anything up to here? Yeah. Between merging and pushing? Sure. So pushing is the process of just putting something onto GitHub. So I could be pushing onto the main branch, or I could be pushing on a different branch built off of the main branch. Like let's say I made a branch just for a feature. And so I could be pushing onto that branch. Merging is the process of taking 2 branches and putting them together. So if I want the code I put on that different branch onto the main branch now, then I'll merge the 2 branches. Which is, so I could push to the main branch, or I could push to a different branch and then merge that. Does that make sense? Okay. Any other questions? Okay. So now we're going to transition to the demo.
All right, okay. Yes, that is true. The lag is real. Okay. All right, so let's get started with the demo. Okay, first I'm going to show you how to create a new repository on GitHub. All right, so here is GitHub. You need to create an account, and you can just like create one with your personal email. So here's how to create a new repository. Cool. So new repository, just click on this little plus button in the corner. Click on new repository. All right, and let's give our repository a creative name, such as lecture 1 demo. All right, and very important here, you need to make sure that your repository is private because you don't want to violate academic integrity. So, private. All right, and now you can just create the repository. All right, and we have this empty private repository right now, and you can tell it's private because of the little notice here. And now Android Studio. It is time to create our first project. So we have Android Studio pulled up. Let's create a new project. All right, phone, tablet. All right, let's create an empty activity. Click on next. All right, I'm just gonna also call this lecture 1 demo. And just gonna stick with the default settings and click finish. And now what happens is Android Studio will just like sort of like auto-generate a whole bunch of code for you. You know, you saw like those like the res folder and all its subfolders. So it'll basically just be auto-generating that, and you can see it's creating the main activity for us. Very cool Android Studio. And yeah, so it takes a bit for it to set up, so we're just gonna wait for it. You can see that Grado is downloading a whole bunch of things, and that's normal at the beginning when you start a new project. Just has to go and download a whole bunch of dependencies so that you can successfully run your code. Yada, 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 yada. Okay, looks good. All right, so before we actually get started coding, I'm going to connect this to version control. So going to VCS here, import into version control, create Git repository. And I'm just gonna create it in downloads because sure. And wait, where do you want me to create this? Okay. Okay, sounds good. Alright, this is in here right now. Let's click OK. Alright, and you can see a whole bunch of red on the left. That's because now that this is a Git project, it's kind of tracking the status, the Git status of all of these things. So now what you want to do is go to Git, go to Remotes, and click on, you want to add a Git remote. And what a Git remote does is it allows this to sort of connect with the repository that we created. And so if I can figure out where the actual browser is. That is a good question. All right. Okay. So here you want to basically be copying this link right here using the little copy button thing. And you want to paste it in the place where it's asking you to add a Git remote. Click on the little plus button to click to add this and click OK. It's going to check the URL. Click OK again. And now what we can do is hopefully push this stuff onto our repository. We can just put everything except the idea folder and then just say, let's say, create project. By the way, can people hear me or no? Good? Okay.
Can I mention something?
Sure.
So, take notice of the fact that what Shirley did here is that she checked what she wanted to be added to the GitHub repo. She said everything except the .idea folder, because the .idea folder is just some random thing that Android Studio generates about how your Android Studio is set up. But it's not actually for the Android app itself. So this was her checking through and putting in stuff.
All right. Sounds good. Okay, so let's see. Now here I'm gonna first commit and Android Studio is gonna perform some code analysis because it's fun like that. All right, commit and now push. So one way you can do this is by clicking the push button here. You can also see it on the top right over here. Yeah. Make sure to push after you commit so that it actually shows up on GitHub. So if I go here now and refresh, you can see all the files that I created locally have been added. Question?
Yeah. So Android Studio has Git inside of it already, so you don't need to get up that top of Bitbucket.
You should first download Git, but after you download Git, Android Studio has sort of some infrastructure set up for you to work with it, basically.
Okay. And also, even though it's standard Git ignore, you have to
So for me, there is a standard Git ignore. I don't believe it ignores the .idea folder by default. I just found that during like group projects, the .idea folder sometimes causes issues. So, but you can definitely add it to the git ignore if you want to, so you don't have to check it every time.
Also, just to keep everybody in the loop, if you don't know what a git ignore is, it's a file that GitHub automatically gives you if there's certain files you never want uploaded to your repo. So like the .idea folder, we were talking about how it's not useful, so you could add that to your .git ignore. So you're saying, hey GitHub, ignore the file, and actually want to find GitHub repo.
All right, sounds good. And now we have our code on GitHub. Let's actually get to writing some code. So here we have the resources folder, and let's go to activity main, which it's inside the layout folder, so it sort of contains a layout for our main activity. You can toggle between different views here. I'm going to toggle to the split view, which brings up code on the left and some sort of like a preview of the screen on the right. So here we already have a text view that says hello world. I'm going to add a button. I'm going to say wrap content. And I am going to add constraints because Android Studio is not going to be happy if you don't constrain it. So one way to add constraints is to actually type in the code for the constraints, but another way is to actually just like drag the constraints to where you want them to be. And so if you constrain it to like the parent, which is like the screen, and you constrain the bottom to like this text here, it's going to sort of like center it in between, like in the middle of the screen and between like the text and like the top of the screen for you. And in addition to that, I want to add an ID to this button so that I can refer to it in my code. All right, sounds good. One last thing. Here in values, we have a string, and so let me just quickly create a string. And you can set that as the text of your button. And here I'm using @string because I defined it in string. And you can see that the preview shows up. Questions as to what I did so far? Creating a button, adding a string resource, adding it as text to the button. Okay. Yeah, so for VCS, you have to like first like you have to first like go to import from version control and like make it into a Git repo first before. Oh, interesting. This is something for after lecture. Come up to us for an after lecture.
Also, I just want to emphasize all of this will be posted online, like the recording, so you don't have to like follow along with it now. You can always go back when you're doing your homework and follow along with the ticket reason website.
Oh no. This is. I forgot to change the language. This thing's in Java. It's in Java.
We are currently recording in Java. This is accidental.